Welcome to East Academia. My name is Brian, and today you're going to talk about evaluating limits through the LHopitals rule. Now, LHopitals rule is usually used when on direct substitution. When on direct substitution, you get an undefined, situations, or 0 over 0, or any number divided by 0, okay? So that is when you can employ the LHopitals rule. And what exactly does the LHopitals rule entail? The LHopitals rule requires that you differentiate the numerator, okay? So differentiate the numerator and also differentiate the denominator and subject these derivatives to the limit, okay? To the limit. And of course, don't worry, because we're going to demonstrate this with an example. Now, as an example, the best way to illustrate it is through an example. So we can have an example of the LHopitals rule. You are told to evaluate the following limit using the LHopitals rule. Of course, for this limit, you can evaluate it using any other method. But here specifically, you've been told to use the LHopitals rule. All right? You can evaluate this limit even through factorization. But here, you are told to use specifically the LHopitals rule. So you are told limit as x approaches to x squared minus 4 over x minus 2. So what is the limit? So solution. So of course, on direct substitution, what do we get? We get it's 4 minus 4 over 2 minus 2, which is 0 over 0, which is indeterminate, okay? Indeterminate or undefined or whatever it is, all right? So using LHopitals rule then, the numerator n is x squared minus 4. And because we want the derivative of the numerator, we are looking for dn over dx, which is going to be 2x. The denominator d is x minus 2. Then the d over dx is 1. All right? So LHopitals rule requires that we subject limit as x approaches 2 of the numerator, the derivative of the numerator, which is 2x over 1. Then you do the substitution. What do we get? We get the answer as 4. All right? The answer as 4. So this is basically the LHopitals rule, whereby you are going to differentiate first derivative of the numerator and first derivative of the denominator and get an answer. Of course, as I said, we can solve this question using another method, a method like factorization. Because when you look at the numerator, this is a difference of 2 squares. You remember we said a plus b, a minus b, you get a difference of 2 squares. So this in essence is x plus 2, x minus 2 over x minus 2, which this and this will cancel. Then you substitute 2. 2 plus 2 is going to give us still 4. All right, so it doesn't matter the method that you're going to use. You will always come back to this one. So now I'm going to take another example 2, before I give you an exercise using the LHopitals rule. So you're told to evaluate the following limit. This is limit as x approaches 1 over x squared plus x minus 2 over x minus 1 using the LHopitals rule. So solution, the numerator is x squared plus x minus 2. So dn over dx, which somebody else can say n prime, okay, as we said in the notation, is going to be 2x plus 1. Then the denominator is x minus 1. So the d over dx, somebody can say d prime, is going to be 1. Then subject this to the limit. So it's going to be limit as x approaches 1 over 2x plus 1 over 1. then the answer becomes what? 3, right? The answer becomes 3. Of course, you can solve this using another method. So for our exercise today, so I'm going to write here, let me just push up, don't have enough room. So our exercise, you're told to evaluate the following limit using the LHopitals rule. Evaluate the following limit using the LHopitals rule, and the limit is limit as x approaches 0, over root 5 plus x, okay, minus root 5 over x. Right? Evaluate the following limit using the LHopitals rule. So pause this video and then try solving it, and then after that you can come and show us what exactly you received as your answer. So thank you for trying. And so according to LHopitals rule, we are supposed to get the derivative of the numerator and denominator independently. So the numerator is square root of 5 plus x minus root 5. The denominator is x. D prime is going to be 1. What about this one, n? So this one we'll have to use chain rule. But for this one, since it's a constant term, the derivative will be 0, okay? This term. So for now, we have, this is the only part that we can differentiate because this is a constant term and the derivative of a constant term is 0. So we can ignore that. So we can say n is equals to, we can let m, let's say let m be 5 plus x such that n is, I can just do that, so that n is m raised to a half, right? dn over dm is going to give us a half, m minus a half, right? And then dm over dx is going to give us 1. Then now the derivative is going to be the product of this and this, right? So dn over dx, what are you going to get? You're going to get it's a half multiplied by m raised to minus a half. So of course this will be in this root 5 plus x, something of that kind. So this is the denominator, the derivative of the denominator. So the derivative of the denominator is 1. The derivative of the numerator is this one. Then you subject now the limit as x approaches 0 of this dn dx, which is 1 over 2, 5 plus x, of course, over 1. So this one, we've put 0, you're going to get it's 1 over 2 root 5. And of course, for this one, you can solve it using any other method, including rationalization and so forth. But this question specifically insisted that you solve using the LHopitals rule. So that is it about LHopitals rule. And we meet in the next video where you are going to talk about different method of evaluating limits, which I think I will show you how to evaluate limits using, you can use these websites to evaluate limits. That will be the next lesson, right? After which we're going to talk about some rules of differentiation. So thank you for watching this video, and remember to subscribe, share, and like, and have a nice time. Thank you.